Hello friends, welcome to my lecture on classification and canonical forms of second order PDE. We will discuss now the case 2. In first case was where s square minus 4 RT was strictly greater than 0. Now we consider the case when s square minus 4 RT is equal to 0. Then the roots lambda 1 lambda 2 of the lambda quadratic equation r lambda square plus s lambda plus t equal to 0 are real and equal. Now in this case what we do is we choose the function u x y in such a way that partial derivative of u with respect to x is equal to lambda 1 times partial derivative of u with respect to y, exactly as in the case 1 where s square minus 4 RT was greater than 0, but the other function b x y can be taken to be any function of x and y which is independent of u x y. So that is the change in this case. Now we then have a equal to 0 because the choice of u x equal to lambda 1 u y makes a equal to 0 as you have seen in the case 1. So a equal to 0 as before, also since s square minus 4 RT is equal to 0. So b square is 1 by 4 s square minus 4 RT into u x b y minus u y b x. U x b y minus u y b x is not equal to 0 because the Jacobian of u and b with respect to x and y is not 0. And therefore s square minus 4 RT equal to 0 gives us b square equal to 0, which implies that v is equal to 0. So we have a equal to 0, v equal to 0 here. Further, c cannot be 0 in this case because otherwise b will be a function of u, but we have already assumed that b is independent of u. So c cannot be equal to 0, and therefore putting a equal to 0 and b equal to 0 in the equation 3 and then dividing by c, we get the equation zvv equal to phi of u v z zu zb, which is the canonical form of 1 in this case. So and this can be then easily integrated. Now let us consider the example of this partial differential equation of second order zxx. So that means or I can write it as r plus 2s plus t equal to 0. R is zxx, s is zxy, t is zyy, and when we compare it with the standard form rr plus ss plus tt plus fxyz pq equal to 0, what we have, r is equal to 1, s is equal to 2 and t equal to 1, which means that if you calculate s square minus 4 RT, this is equal to s square is 4 minus r and t are 1. So 4 minus 4 equal to 0, and so we have case 2. This partial differential equation belongs to the case 2, s square minus 4 RT equal to 0. So what we do, let us find the roots of the lambda quadratic, r lambda square plus s lambda plus t equal to 0. This is the lambda quadratic. R is equal to 1, so we have lambda square, s is equal to 2, so we have 2 lambda, t is equal to 1, so we have lambda square plus 2 lambda plus 1 equal to 0, and this is lambda plus 1 whole square equal to 0, which means that the two values of lambda are equal, they are minus 1 minus 1. Now we have to find the choose the functions u x y and b x y. So let us choose u x y such that partial derivative of u with respect to x equal to lambda 1 times partial derivative of u with respect to y, which gives you u x equal to minus u y, because lambda 1 is equal to minus 1, or I can say partial derivative of u with respect to x plus partial derivative of u with respect to y equal to 0. Now this is Lagrange equation where of the form P P plus Q Q is equal to r, Lagrange equation. Okay. So, here p is partial derivative of u with respect to x, q is partial derivative of u with respect to y, p is equal to 1, q is equal to 1 and r equal to 0. Okay. Now, so we have the characteristic equations, we have the characteristic equation dx divided by 1 dy divided by 1 equal to dz divided du divided by 0, because here the dependent variable is u, and therefore, what we have du equal to 0, which implies u is a constant, say C1, and dx equal to dy gives you dx minus dy equal to 0, or we can say x minus y equal to some constant C2. So, C2 is a function of C1. So, we can say u is a function of x and y. Thus, u is a function of x minus y. Okay. We can take, because we have to choose u, so we can choose u equal to x minus y. Okay. Now, we have to choose b in such a way that b is independent of u. So, let us we may choose b is equal to x plus y, then b is independent of u. Now, let us reduce the given canonical given partial differential equation to the canonical form. So, what we will get, we have to find partial derivative of z with respect to x. So, this is partial derivative of z with respect to u into ux plus partial derivative of z with respect to b into bx, and this is equal to zu into ux is equal to 1, okay, and vx is also 1. So, zu plus zb, and now let us find second order partial derivative of z with respect to x. So, we have this. Okay. So, this is zx we have already found. Okay. So, this is equal to now z is a function of u and b. So, zu is also a function of u and b, and therefore, in order to find the partial derivative of zu with respect to x, instead of z here we put z equal to zu. So, we get we have partial derivative of z with respect to x, zuu into ux, ux is equal to 1, then zu partial derivative of zu with respect to b. So, zub and bx equal to 1. So, this is what we get, and similarly we can find partial derivative of zb. We replace z by zb here. So, we have partial derivative of zb with respect to u. So, we get zub, and then ux is 1, and then zb partial derivative of zb with respect to b is zbb, and bx equal to 1. So, we have got the values of both the partial derivatives, partial derivative of zu with respect to x, partial derivative of zb with respect to x, and thus zxx is equal to we put the values here. So, zuu plus zub, and then this value of this is zub plus zbb. So, this is zuu plus 2 times zub plus zbb. Okay. Now, let us find this s. Okay. So, we have to differentiate this partial derivative of z with respect to x by with respect to y. So, what we get, let us differentiate. So, delta over delta y of delta z by delta x, this is equal to partial derivative of zu with respect to y plus partial derivative of ZB with respect to y. And these values can be found from here. We have to differentiate. We have not differentiated so far z with respect to y. So let us write partial derivative of z with respect to y. So this is zu into uy plus zb into by. And how much is that? Uy is equal to -1, so we get minus zu, and by equal to 1, so we get zb. Okay. Now we differentiate zu, okay, with respect to y. So this gives you, we can replace z by zu here, and when we do that, this is minus zuu plus zub, and partial derivative of zb with respect to y can similarly be obtained. Replace z by zb there, so we get minus zub plus zbb. All right. So this is equal to, we can put the values now, minus zuu plus zub, and then minus zub plus zbb. So this cancels with this, and we get minus zuu plus zbb. We still have to find this term. Okay. So we have got the derivative of z with respect to y. We can find now second derivative of z with respect to y. So delta square over delta y square z, this is equal to this. Okay. And this gives you zy is equal to minus zu plus zb. So this is minus this. Okay. In order to find the partial derivative of zu with respect to y, replace z by zu there. Okay. So we get minus zu okay, plus zub. Okay. And then we find partial derivative of zb with respect to y, is replace z by zb there. So we get minus zub plus zbb. Okay. And when you multiply this minus 1 inside, what you get is zuu minus zub minus zub plus zbb. So this gives you zuu minus 2 zub plus zbb. Okay. Now let us put the values in the given PDE. Okay. So we have found the value of zxx. Zxx is zuu. So the given PDE transforms to, okay, so zxx is zuu plus 2 zub plus zbb. All right, plus 2 times zxy. Zxy we found here. Okay. Partial derivative of zx with respect to y we found, and it is minus zuu plus zbb, and then plus second order derivative of z with respect to y, which is zuu minus 2 zub plus zbb. Let us see what we get. Okay. So zuu plus zuu dash zuu, which will cancel with minus 2 zuu here. Okay. And zbb will be equal to we have 2ZUB here and 2ZUB here. So, this term cancels with this term and 2ZUB cancels with 2ZUB. Okay. What we have? ZBB plus 2ZBB plus ZBB. So, this is 4 times ZBB equal to 0. Okay. So, this gives you R delta square Z over delta B square equal to 0. Okay, this is what we get. So, this is the canonical form here. You can see 4 delta square Z over delta B square equal to 0. Now, we can find the general solution also here, because this is now simple, we can easily integrate this. So, this gives you delta square Z over delta B square equal to 0, and which implies that when we integrating with respect to V, okay, keeping U as fixed, we get delta Z by delta V equal to some function of U. So, we get phi 1 U, okay, because we are considering, while integrating, we are considering U as a constant. So, the arbitrary function will depend on this, phi 1 will depend on U, and then we will integrate it further with respect to B. So, we get Z equal to B times phi 1 U plus phi 2 U. Okay. Now, let us see the values of U and B. Okay. So, value of U is what? U is equal to x minus y, B equal to x plus y. So, let us put that. So, since U is equal to x minus y and B equal to x plus y, we get Z equal to x plus y into phi 1 x minus y plus phi 2 x minus y. So, this is the general solution of the given PDE here. Okay. Now, let us consider the third case when s square minus 4 RT is less than 0. So, when s square minus 4 RT is less than 0, then the roots lambda 1 and lambda 2 of the lambda quadratic are complex conjugates. Hence, in this case, the equation 3 is formally same as equation 3. In case 1, we had taken lambda 1 and lambda 2 be real and distinct. Here lambda 1 and lambda 2 are distinct, but they are complex conjugates of each other. So, this case is formally same as case 1. Therefore, proceeding as in case 1, we find that 1 reduces to 8. But that the variables U and B, instead of being real, are now complex conjugates. So, the functions U and B are now not real functions, they are rather complex conjugates of each other. So, to obtain a real canonical form, let us make further substitution. Okay. Since U is a complex function of x and y, we can put U equal to alpha plus I beta, where alpha beta are functions of x and y, and V as alpha minus I beta, because B is a complex conjugate of U. So, then you can find the values of U and alpha and beta. Alpha is equal to U plus B by 2, beta is equal to minus I times U minus B by 2. Alpha is, so we get the values of alpha and beta, and then we use the transformation, we can reduce the given form to this one. You see, because 1 reduces to 8 and 8 is of the form ZUB equal to a function of x, y, z, ZU, ZB. So, what we do is we get the value of ZUB in terms of the partial derivatives of z with respect to alpha and beta. So, let us look at this transformation. Z is a function of U. So, partial derivative of z with respect to is partial derivative of z with respect to alpha into partial derivative of alpha with respect to U plus partial derivative of z with respect to beta into partial derivative of beta with respect to U. And if since alpha is equal to U plus B by 2, we have alpha is equal to U plus B by 2. So, what we get? Alpha U equal to half, alpha B equal to half. So, and beta is equal to beta is equal to here 2 I beta equal to 2I beta equal to alpha u minus b equal to I beta. So, beta is equal to 1 over 2I into u minus b. So, this means that 1 over I is minus I. So, we get u minus b is equal to 2I beta. So, beta is equal to 1 by 2I, I square is equal to minus 1. So, 1 over I, so I is equal to minus 1 over I. So, 1 over I is minus I. So, this will be 1 over I by 2 into b minus u. 1 over I is minus I. So, 1 over I by 2 b minus u, and therefore, beta u will be equal to minus I by 2. Beta u will be minus I by 2. So, we get here beta is equal to I times b minus u by 2. So, beta u is equal to minus I by 2, and therefore, what we have here 1 by 2 z alpha minus I z beta, 1 by 2 times z alpha minus I z beta. Alpha b is equal to half and beta b equal to I by 2. So, here z alpha b is equal to half, beta b equal to I by 2. So, we can get this, okay, and we have z u like this. Then we differentiate z u with respect to v, okay. So, what we have z u b, okay. Or we can use in order to find z u b, we can use the differential operators. This is equal to 1 by 2 delta over delta alpha minus I times delta over delta beta of z. So, this is the differential operator, and here 1 by 2 delta over delta alpha plus I times delta over delta beta, okay, z in the form of differential operator. So, z u b is equal to 1 the partial derivative with respect to u into partial derivative of z with respect to b. So, this partial derivative, this is what this is, okay. So, z u is partial derivative of z with respect to u. So, this part differential operator delta over delta u is equal to half of this. So, 1 by 2 delta over delta alpha minus I delta over delta beta into half delta z over delta alpha plus I delta z over delta beta. Now, when you apply delta over delta alpha to this is 1 by 2 into 1 by 2 is 1 by 4. So, delta over delta alpha when applies to delta z over delta alpha gives you z alpha alpha. Then delta over delta alpha applies to I delta z over delta beta gives you I times z alpha beta. And then minus I delta over delta beta applies to this gives you minus z I times z alpha beta, and then you get minus I square is minus 1. So, minus I square becomes plus 1, and then we get z beta beta. So, this cancels and we get 1 by 4 z alpha alpha plus z beta beta, and therefore, putting u equal to alpha plus I beta, b equal to alpha minus I beta, the equation 8 reduces to z alpha alpha plus z beta beta equal to a function of alpha beta z and then z alpha and z beta. Now, this is the canonical form in the case of 3 where s square minus 4 RT is less than 0. Now, let us consider this problem and we will reduce it to the canonical form. So, this is a second order partial differential equation. We have here r plus x square into t equal to 0. So, let us find the compare it with r plus s s plus t t plus f x by z p q equal to 0. If we compare it with this, what we get? R is equal to 1, s is equal to 0 and t equal to x square. So, s square minus 4 RT, s is 0, so this is 0 minus 4 x square we get. which is less than 0. So, this partial differential equation belongs to the type 3 where s square minus 4 r t is less than 0. Now, let us write. So, here the roots are complex conjugates, lambda 1 and lambda 2 are complex conjugates. Let us find lambda 1 and lambda 2. So, consider the lambda quadratic. R lambda square plus S lambda plus t equal to 0. So, R is equal to 1, so we get lambda square, S is equal to 0, t is x square, so lambda square plus x square is equal to 0, so lambda is equal to plus minus Ix. So, we can see that lambda 1 is Ix, okay. So, let lambda 1 be Ix and lambda 2 be minus Ix. So, the roots lambda 1 lambda 2 of the lambda quadratic are both complex. So, what we get is we proceed in this manner, delta u by delta x equal to lambda 1 delta u by delta y and delta b by delta x equal to lambda 2 into delta b over delta y. So, they will give you delta u by delta x equal to I1 is Ix, lambda 1 is Ix, so Ix into delta u by delta y and delta b by delta x equal to minus Ix delta b by delta y. Now, so let us take this equation, okay. So, this can be written as now this is Lagrange equation of the form Pp plus Qq equal to R, okay, where P and Q are this Ux and Uy, okay. So, P is equal to 1 and Q equal to minus Ix, R is equal to 0. So, the characteristics equations are dx over 1 equal to dy over minus Ix equal to du over 0, and which implies that du equal to 0 and dy plus Ix dx is equal to 0. Okay. So, du equal to 0 gives you u equal to some constant C1, and here what we get is by plus I x square by 2 equal to some constant C2. Now, C2 is a function of C1, okay. So, we can write by plus u equal to thus u equal to a function of by plus I x square by 2, okay. And in a similar manner this other characteristic equation this bx plus Ix by equal to 0 implies that b is equal to instead of Ix minus Ix, now we have plus Ix. So, this we will get by b equal to psi by minus Ix square by 2. Okay. Let us choose u to be by plus I x square by 2 and b to be by minus I x square by 2. Okay. Then what will happen, alpha is equal to u, we have considered, we have taken u equal to alpha plus I beta, b equal to alpha minus I beta. Okay. So, u is equal to so alpha is equal to 2 alpha is equal to u plus b by 2 u plus b. So, u plus b by 2 equal to alpha and 2 I beta, okay, is equal to u minus b. So, beta is equal to 1 by 2 I into u minus b. Okay, so u plus b is equal to 2y. Okay, so this implies alpha is equal to y and beta is equal to u minus b. U minus b is beta is equal to x square by 2. This is u minus b equal to 2i x square by 2. So, beta is equal to x square by 2. Okay. Now, what we have? So, let us now convert this equation zxx plus x square z by y equal to 0 to its canonical form. Okay. So, let us find partial derivative of z with respect to x. So, we have okay. So, alpha x equal to 0, alpha y equal to 1, beta x equal to x and beta y equal to 0. Okay. So, what do you get? Alpha x is equal to 0. So, z alpha into 0, z beta into beta x, that is x. So, we get x into z beta. Let us find again second derivative. So, delta square z by delta x square is delta over delta x of delta z by delta x, which gives you x z beta. Okay. So, this is a product of functions of x. So, derivative with respect to x, when we differentiate x with respect to x, we get 1. So, 1 into z beta plus x times partial derivative of z beta with respect to x. Okay. Now, partial derivative of z beta with respect to x can be found from here. Z is any function of alpha beta. So, z beta is also function of alpha beta. So, this will give you when you put z y z beta here, we get here delta over delta x of z beta as x times z beta beta. So, what you get? Z beta plus x square z beta beta. Okay. So, this is what we get, and then z y. Let us find z y. So, delta alpha y plus z beta beta y. So, this is equal to delta alpha over delta y equal to 1. Okay. So, we get z alpha and then z beta y equal to 0. So, 0 z beta into 0. So, we get here z alpha only. Okay. Now, let us find then delta square over z over delta y square will be equal to delta over delta y of z y, but z y is z alpha. So, z alpha here, and when you find this derivative, replace z y z alpha here. So, what do we get? Z alpha alpha. Okay. So, now put the values. So, then okay, zxx plus x square z by y equal to 0 gives us zxx is how much? We found zxx here, zxx as this. Okay. This is zxx. So, z beta plus x square z beta beta plus x square times z y y. Z y y is z alpha alpha equal to 0. Okay. Or z beta plus x square times z alpha alpha plus z beta beta equal to 0, and x square is equal to 2 beta. Okay. So, what you get? We have z beta plus x square is 2 beta. So, 2 beta times z alpha alpha plus z beta beta equal to 0, and this gives you z alpha alpha plus z beta beta equal to minus 1 over 2 beta z beta. Okay. So, this is the required canonical form. Okay. Z alpha alpha plus z beta beta equal to minus 1 over 2 beta z beta. That is all in this lecture. Thank you very much for your attention.